Hello guys, this is Trockers. Welcome back to my channel. I believe we are getting better in terms of solving geometric series problem. Okay, so we have a problem before us here. That's a ZIMSEC June 2018 paper 1. Show that summation from r is equals to 1 up to 16 of this is equal to that. Right, so here we need to understand what type of sequence. We need to understand what type of sequence is this when we plug in. So for example, when r is 1, we have root 3. When r is 2, we have root 3 squared. Don't simplify, though we know it's 3, but if you simplify, you might not be able to see the pattern. When r is 3, we have root 3 cubed. So from these three terms, I can actually see that that's a geometric series, right? Where my first term is root of 3 and my ratio is root of 3, and I'm now summing 16 terms. And I would think of the sum of finite terms here. We're going to use a since r is more than 1, we're going to use our r to the n minus 1 over r minus 1, because in this case our common ratio is more than 1, so we use this one, right? So with that being said, guys, let's see how we solve this problem out. Okay, we have summation. Sorry. All right. We have summation from r equal to 1 to 16 of root of 3 to the r. We want to show that it's identical to 9840 plus 3280 square root of 3. Right, so let's deal with the left-hand side. So like what I've said, the left-hand side is a GP, right, with a equal to root of 3 and r equal to root of 3. So we want to find sum of 16 terms, right? Sum of 16 terms. Remember, for sum of n, since r is more than 1, we are going to use a r to the n minus 1 over r minus 1. So now sum of 16 is my a, which is root of 3. Then my r is root of 3 to the power of 16 minus 1 over root of 3 minus 1. Right. So here we can simplify the top first, right, which is root of 3 times. Right. So here, by simplifying this, if we say square root of 3 to the power of 16. So square root of 3 to the power of 16, let's see what we get. To the power of 16, right? I'm getting 6561, so it's 6561 minus 1 over root 3 minus 1, which is equal to this times that 6561 minus 1, which is just equal to 6560 root of 3 over root 3 minus 1. So here we can rationalize, right? By rationalizing, we are trying to make the denominator a whole number without the radical. So we rationalize by multiplying top and bottom by the conjugate, right? Okay, so when we multiply here, obviously that's the difference of two squares, so it's the same as saying root 3 squared minus 1 squared over, so this times that, so root 3 times root 3 is 3, so 3 times 65660, right, times 3, I'm getting 19680, then plus this times that, it's 6560 root of 3, right? And this simplifies to 19680 plus 6560 root of 3 divided by 2. So when I divide that by, remember root 3 squared is 3 minus 1, that's 2. So when I divide this by 2, I'm getting 9840 plus 6560 divided by 2, I'm getting 3280 root of 3. Then we are done, right? Even if you try to go back to the question, guys, we are trying to show that it's 9840 plus 3280 square root of 3, which is exactly what we have here, 9840 plus 3280 square root of 3. Guys, let's continue to do more practice. I'm signing out. Later.